Hello, this is Dr. Liu, and in this video I would like to share some exciting updates to the firmware of the SDI12 USB adapters. So as you already probably have seen this micro USB, and this update of firmware is actually for this extension. This is an optional input. It says inputs, so there are 4 channels that you can use to read the analog voltages. You can also read digital on and off states, and you can also read or count pulses. So that has been there for quite some time, and this updated firmware makes this connector, the 4 channels, even more powerful. And let's go ahead and take a look. So the update actually concerns these features on the additional 4 channels on top of the adapter. So one of the features is analog read channels. And in the past, we could actually do this with a command, the ZM8. And the ZM8 reads all 4 channels analog voltage and also replies with the digital voltage. But that happens with all 4 channels in a group. So if you are doing something else on those channels, such as if you had a pulse counter on one of the channels for, say, a rain gauge, and then that pulse counter is affected by analog read, which will update all channels. So in the past, it's basically either you use the channels as all analog channels, or you use them as just pulse counters and maybe not as analog channels anymore. And in this update, all the channels can be individually addressed. So you can have, for instance, you can have a couple of pulse counters and maybe an analog input and also another digital input. So they'll all act independently. So I want to go through how to do that. So you can read analog voltages, you can do a digital read, you can also do pulse count, and for a bit more advanced users, there's also options there that you can do digital output, high or low. You can control your lights, your pumps, your relays. So that's for a bit more advanced application. So let's keep going. So here we have, based on the existing ZM syntax, M means measurement. So here is just a square bracket with a single character as an additional command. So we used to have this ZM8. If this whole thing is 8, that senses analog voltages. ZM9 will just do the digital counter, the pulse counters. So now there are some new mnemonics, and the existing ones still work. These are just new ones now. And my recommendation is, if you feel like the new ones are fulfilling your requirements, don't use the old ones anymore. So transition to the new ones. So here are mnemonics for reading sensors. So if I have an A here, like ZMA, it would mean read analog voltages. So if we don't specify any channel number, this ZMA and exclamation sign, it reads in all 4 analog channels. But if you only need, say, a certain channel, and you can actually specify what channel you want to read. For instance, you can say ZMA0 exclamation sign. So that only reads analog channel 0. It'll leave the channels 1, 2, 3 alone. If those channels are doing something else, such as keeping pulse counts, and they will not be disturbed. And that makes it basically individually addressable. So A is for analog read, and D is for digital read, and P is for pulse read, pulse counter read. So if you want to do a digital read, you can say ZMD, and then you can list a number of channels. You can go like ZMD 1, 2, 3. That would read channels 1, 2, and 3, and without touching channel 0. In case channel 0 is doing something else that doesn't want to be disturbed. And here's another example, reading pulse counters channel 2 and 3, and that reads these channels for their pulse counters, and the command leaves channel 0 and channel 1 alone if they're actually doing some analog inputs, because settings could be mutually interfering. If you're doing pulse counters the pull-up internal pull-up resistors are enabled. But if you're reading analog voltages and your analog input is high impedance, is weak, then you don't want that internal pull-up resistor. But if you read analog voltage on a pulse counter, and then you basically disable that pull-up, and that could interfere with further reading pulses. So now you can just say, well, if you want to map out the 4 channels to whichever channel does what, then you can just keep let them do their own thing. The commands won't really interfere with other channels. So here are some additional mnemonics. So this is analog read when you're reading all the channels or any channel you specify without enabling a pull-up resistor. So that is for basically for all analog channels, you can read it that way. But the B, it modifies the analog read by enabling the pull-up resistor. So why would I do that? Well, for certain cases you could. It wouldn't make a difference. For instance, if your sensor outputs a voltage, and this voltage is not very weak, so it's something that's output from a say a temperature sensor. I'm just making up. Say it outputs 0 to 2 volts to map out a whole range of temperature it measures. So having the pull up when you're reading analog signal is advantageous in this case, because if the sensor is disconnected somehow, and the analog with a pull up will always read near 5 volts. So it has its special uses, but it's not very common to do that. So I still have that just in case you need it. And E actually is extension to the D, digital read, and the E does the digital read without pull up. I have thought about this. What are the possible use cases? I haven't come up with anything, but I'm pretty sure someone might come up with something and say, well, this thing has this strong or weak pull down resistor that I cannot remove. So if the pull up is enabled, it's gonna interfere here and there, something like that. So there might be some use cases for that, but it is less used. I would expect these A and D and P to be the most commonly used mnemonics. So basically this is where the mnemonics go, and then you can also have an optional list of channel numbers, or if you have no channel numbers, then all channels are treated the same way. They're all affected. And besides reading sensors, now we also have control of actuators. So before we go on to this, I need to warn you, you shouldn't use these commands when you connect a channel to a sensor. The sensors shouldn't be actuated. So the purpose of these control commands is to control lights or pumps, or maybe relays that if you apply a 5 volt, you may actuate the relay. Apply 0 volt, you can disengage the relay, for instance. So that's for controlling actuators, not for reading sensors. So be careful, these are not for sensors. And what we can do here is we can control a certain channel to have it output high or have it output low. And the mnemonics is just H for high and L for low. So the H basically sets high for channels 1 and 2. And you can also do something like a ZML 0 or just ZML 1 to set channel 0 or channel 1 to low. And you can have a full list of channels after 4 channel numbers for sure, right? So this is for a bit more advanced users who want to incorporate a feedback loop. For instance, if certain measurement values are below or above a certain range, you want to actuate something. Maybe you turn on a fan to cool off the temperature. Maybe you turn on the pump because say soil is too dry. So that gives you basic control up to 4 channels. All right, so let's keep going. These are the examples. So if you want to do analog read channels without pull-ups, this is the most common analog read mode. So it works for any analog signal that goes between 0 volt and 5 volts, and you can also read the resistance, but you need a voltage divider. So the new command is the ZMA, A for analog, and then you can read one channel if you specify a number right after the A, or you can read 2, 3 channels or all channels. And it provides a channel list or channels list, such as this ZMA02. It means to read analog voltages through channels 0 and 2. And then the response will only have those two values. Instead of having 4 values, then you have to pick them out, the one that you need. And if you read all channels, it'll just be ZMA. And it works the same way as ZM8. That was the old command. Now it still is functional, but if you're designing new setups, I would encourage you to use the new command, so that eventually I may retire the old commands at some point, or even repurpose it for some other types of sensors. So then, as you're reading these channels, the other channels that you're not reading are not affected. So if their digital counters, their counts will not slip or will not be uncounted, because if you do read analog voltage from a pulse counter input, you're going to disable the pull-up resistor. So that will actually sometimes will not work, because the digital counters, some of the counters, how they're designed. Okay, so these are some examples, just a sequence. The black is your command that you issue, and the white is the adapter's response. Say if you want to read channels 1 and 2, you just issue a ZMA12 and exclamation sign. Remember, there's no return or backslash r/n. Your command always ends with this exclamation sign, and the adapter response is just like an SDI12 sensor response, always ends with /r/n. So the white is response. So this the adapter will respond with Z001, which means it takes 1 second to get everything back, to return the values, and then the 2 means 2 values are returned because you were asking to read 2 channels. And then it'll further issue this so-called service command, or not service command, service request, so that you will actually know that it has completed its measurement. And then you will issue a ZD0 exclamation sign to extract the data. And this is just a sample data set that channel 1 has 1.23, channel 2 has 3.45. So that's one example. This is another example where you want to read all channels. So you can just ignore the list of channels, or you just say 0, 1, 2, 3 if you want. And then it will respond with 001, that's 1 second, and then 4 means 4 values will be returned. And then it'll issue this service request again, and you will issue the D0 to read the values out. So there's 1, 2, 3, 4 values, and /r/n. And here's just another example. What if you just want to read 1 channel? Well, you just include 1 channel's number, and it'll say that only 1 number is going to be returned, and as you read it, only 1 number is returned. Okay. So that's analog read without pull-up resistor. That's the most common scenario that we encounter. This one with some red text is because this is with the pull-up resistors, so it has the capability to detect a disconnection, because when you're disconnected, then the pull-up resistor will pull the analog signal up to 5 volts. It may not show as 5, but it may show as 495, something close to it. And you can say that if the voltage is greater than, say, 4.9, then determine that it has no sensor connected to it. So this works only on the strong analog voltage signals, not the weak ones, such as say voltage dividers. So remember that this is not a very common use case. If you have questions, you can let me know. I can explain where can you actually use this. Okay, so then the command is B, just like A is analog, B is just the next letter, so I use that. And the same exact syntax, if you wish to have 2 channels, you just issue the 2 channels numbers, and they'll return 2 channels values. And here's an example where channel 3 is actually disconnected, so it reads a 5 or close to 5. and here's just reading one channel. You just issue one channel's number behind the B, and then it returns one value. Okay, so now digital read. This is the most common scenario with pull-up resistors when you're doing digital read, and it works for any voltage up to 5 volts of digital signal. And this new command is just ZMD, D for digital, and you can issue a list of channel numbers if you wish, such as this. We'll just read the channel 0 and the channel 2. And this is the same as the ZM8 if you issue the ZD1 to extract the digital readout. So if you're designing something new, I would encourage you to use this instead of using the ZM8, which is an older command. And then also, whichever channel you're reading, you're not affecting the channels you're not reading. So if the other channels are not supposed to be digital channels, and they're supposed to be something else, such as analog channels or pulse counters, then those channels are not read, they're not affected. So these are some examples, such as reading channel 1 and 2, and you just issue this command ZMD12 exclamation sign. It'll tell you that it's going to return 2 values, and later if you read, it gets 2 values, such as this and that. That means both are high or true. And if you're reading all of them, you don't need to do a list. You just do ZMD, D for digital. It'll say it's going to return 4 values, and these are the 4 values that it returns. Or if you want to just read one channel, just give it a number, and then it says it'll return one number, which is going to be just one number. Okay, so the next one is I haven't really thought about what exact use case this could apply to, but it could be useful. So this is reading digital channels without any pull-up resistors. So mostly you would not really use it, but just in case, right, this is here. So the entire syntax, everything is the same, except that the pull-up resistors are not enabled. Okay, so I'll skip over this. Okay, so now pulse counter. Alright, so any clean pulse between 2.5 volt to 5 volt will be detected as a pulse. And if you don't have a clean signal, you may want to use an RC circuit to filter it so that it becomes clean enough to count. So this is just like before. The pulse counters count both low to high transitions and high to low transitions, because certain encoders, low to high and high to low, they don't just happen in a pair. They could happen just at one of them, and that means both transitions are meaningful in those encoders. So my decision is to have both transitions up and down, from low to high, high to low. They're both counted. So if your encoder or your pulse generator only just generates a full pulse for, say, a meaningful thing, then your result will be twice as high. You always just divide by 2. So if you have a pulse from low to high, high to low, then low to high is one transition, high to low is another transition. So it counts as 2 transitions, or we can call it transition counters. Okay, so the new command is ZMP. So you can issue a list of channels, and it'll only return those pulses. So this means if you want to count, for instance, I'm just making it up, something that's fast, it counts a lot of pulses per certain time, you can issue the read command more frequently. And if there's another pulse counter that's counting something relatively slow, and you want it to be accurate enough, so you want a longer period of time before you read in the counts, and you can just issue those pulse counter counts on a different time to loop. So. And if you want to read all the pulse counters, it's just going to be ZMP, P for pulse. And that's the same as ZM9. And I encourage you to use the new command if you're designing something new or just trying to update your existing code. And again, the channels that are not read, they're not affected by this command. So if there's an analog channel there, if there's maybe a relay that you're actuating on one of the channels, and they will not get affected because you read some other channels. Okay, so the syntax is very similar to analog and digital read, and it's just it returns the pulse counts. So if you want to read channel 1 and 2's pulse counts, just ZMB12 exclamation sign. It'll say that it's going to return 2 values. Later it'll say, well, it's ready, and then you read it in, and then there are 2 values. So I'm making it up, but they're all, most of them are odd numbers. I realize I probably should have made up some even numbers as well. Anyway, so if you read in all channels, you don't have to specify a list of channels, or you could if you want, and then it'll return 4 counts, and there. Or you just read in one channel, it returns 1 count. And just like before, as you read in the counts, the adapter clears the counts, so that next time we read in, it's going to be the counts since last time we read. So you can do your own timing. If you want to do this read out once per minute, then the count will be exactly counts per minute. If you want to read this once per hour, and the counts will be counts per hour. So whatever unit your experiment is going to need, you can just read it with your timed loop. Okay, so all right, so now let's talk about these. So careful here. We can actually set channels into an output channel. So that means if you have a channel, you want to drive a pump, maybe drive a relay, and if they accept 0 to 5 volts to control their states, you can use these channels to control their states. And again, if you only need to use say 1 or a couple channels for that, and the rest of the channels you still want them to connect to your sensors, yes, you can do that. You just configure the channels you have actuators on, and the other channels are not affected. So careful, do not set any channels to high or low, actually, that are connected to sensors. You may damage the sensor or the adapter or both, because sensors are supposed to output to the adapter. The adapter should be reading in as input. It shouldn't also try to output to the same line. That's contention. Okay. So this command is going to set the output to 5 volt or high to actuate some lights, pumps, and relays. But do remember, some of these things, when you set them to low, they actuate. When you set them to high, they turn off. So it really depends on the device you're trying to actuate. So it's best to read their instructions. Some of the relays are especially made that way. You can set a low to actuate and set to high to turn it off. So just make sure you know which way for your device. So the mnemonics, excuse me, the new command mnemonics is H, so ZMH for high, and you can set any channel in the list, such as ZMH02, it'll set these channels to high. And again, the configuration doesn't affect other channels. So before I go into the example, I want to say that although you can drive things to high, 5 volts for instance, and drive things to low, the channels can only source or sync up to 20 milliamps of current, and at 20 milliamps the voltage is not going to be 5 volts. It's probably close to 3 point something volt. So this is supposed to be a signal to give to your device instead of being a power source to power your device, unless your device is very say power efficient. Maybe 5 milliamps is enough to power something. Maybe, then you could certainly use this to power up a small device and turn it off if you want. But you can't expect this 5 volt to somehow power a pump, right? The pump needs its own power source. The 5 volt is just telling the pump to start pumping, not to power the pump. Okay, so now continue to the sequence here. The sequence is slightly different because we're no longer reading sensors. We're actually actuating something. So we don't have to have something that responds back with numbers. Okay, so that changes things. For instance, if you want to set these 2 channels, 1 and 2 to 5 volt, and you just say ZMH for high, 1, 2. And then the device will respond as Z/R/N, because it just responds and says accepted, it'll do it. And there's no more stage to read data in or being told how many values are going to be responded. So let's switch back to this pulse counter. See that? This additional line here is the device is saying it takes 1 second to return 2 values. Well, if you're just setting a channel to high or low, no values are returned. So this line is not present. Only this line is present to tell you that, yeah, you got it. And then you also don't need to issue a read data command because it's not reading data. It's just setting a channel. Okay, so that is not needed. That's not needed. So that means whatever you do, it'll just respond with z \r\n. So if you want to set all channels to high, that is the command. Set a single channel 0 to high, that is your command. Oh, I see. That's actually not the command, right? It's I think it's a typo there, because I copied it from a previous slide. So this should be high here. Does that mean also this is wrong? No, actually this was correct. Okay, reload again. Okay, back here. So setting channel 0 to high, that's a command. And what if you want to set it to low? Okay, same exact warning again. Don't connect this to sensors. This is supposed to be connected to this actuator that receive commands to turn on and off. So the pneumatics is an L, so ZML set to low. So sets these channels to low, you just give a list of channels. And again, the device only responds with this line, and there's nothing else to do. So you just set the channel to low. Okay, so hope this is good enough to give you an idea how to do this thing. And what I'll do over here is I'm going to use an adapter here and do some of these commands. So let's actually do analog channel. So okay, so analog channel. So let me see what I have connected. Okay, so I have channel 2 connected to something, to a large resistor. So without pull-up resistor, it should actually read 0 because the other side of the resistor is connected to the ground. So I can do ZM analog. So channel 2. So there, that's it. Okay, it says I'm returning 1 value within 1 second. Okay, I'm ready to return the value. So all you have to do is do the Z D0, and I have it on the button. There you go. So it reads 0. And can I read something else? I don't really have something that can create a different voltage. So yeah, that's too bad. So what if I want to read this? Read with pull-up resistors. Oh, actually, you know what? I have an idea. What if I read in all of the other channels just to see? There's an idea there. So I'm just going to not have a list of channels or have a list of 0, 1, 2, 3. So this reads in 4 values. And let's read, let's see what they are. Oh, that's interesting. This one I know because I connected this channel to the ground with through a resistor. But what is this? 0.69. These two seem to be really close to each other, but okay, let me do another read on all the 4 channels again and get the data back. Woo, that's interesting. Okay, except for this number, which is constant because I tied that channel to ground, right? This changes quite a bit. 7 to a 6, that's more than 10% change. And these also change quite a lot, but they somehow trace each other. So here is a word of warning. If you have an analog channel and you don't have a sensor hooked up to it, you will read random voltage, just like this and that. But why are we reading the same random voltage over here? Well, that's because I had these 2 channels connected to each other. Although they're randomly fluctuating, they have to fluctuate the same exact voltage because I connected the 2 channels together. So that was for a different purpose, but this is just showing you. If I do another read, so CMA again, do another read, see the values will gradually change. If I have my finger on these channels, I'm pretty sure the values, see that the values will change, and this even changes slightly, but it's close enough to 0. Okay, so as you can see, if you have nothing connected to an analog channel without a pull-up resistor, you're going to read some random values. So I think that I explained this in some other videos as well, but it's just another opportunity. But if you read it with a pull-up resistor, Well then, let's try that. So remember, channel 1 and 2 are connected to each other. Channel 0 and 1 are connected to each other. Channel 2 has a resistor connected to the ground. Channel 3 is completely floating. Okay, so let's read. Well, look at that. So these are almost 5 volts. So let's see if they actually stick. So let's read one more time. And okay, so the voltages are not really changing much at all. So let's read one more time. CD0. Right, the voltages don't change. So here is the benefit of having a pull-up resistor, if your sensor can allow that, is if there's no sensors connected like this channel and that channel, they're connected to each other, but they're not connected to any sensors. This also not connected to any sensors. So you can see the voltage approaches 4.95, close enough to 5 volts. So you know if you have analog reading with pull-up resistors, then values like this will only tell you that there's no sensor connected. But why is this? It was a 0 before. But remember, the 0 was obtained by connecting the sensor, the channel 2, through a large resistor to the ground. So if I have a pull-up, effectively the pull-up resistor and that other large resistor, they formed a voltage divider. So you're dividing the 5 volt into 3.6 volts. I bet my resistor is larger than the internal pull-up resistor, which has a range of about 40 kilo ohms. The one I have is about 100 kilo ohms. So anyway, each command has its own application there. Okay, so let's go on to digital read. I don't really have any digital signal here, so let's just do digital read channel 1. So this is with a pull up, so you'll expect the results to be pulled up to 5 volts. So it's gonna be a 1 or 2. So just like that. If you only issue the command with one channel number. So what if I have what is 3? 3 has nothing connected to it. Yeah, so then you'll also be pulled up to high. So return 2 values. So these are the 2 values. All right. So I'll skip out this. This is basically the same, except that using E instead of D. Okay, here's the pulse counter. Well, I don't have anything that can output pulse. But wait a minute, I could flip my digital channels to from high to low, low to high, and feed it to another channel to count it. Yay, that's gonna work. So let me do this. First, I want to read the pulse from channel 0. So this sets up the channel to count pulses. So you must read it once at least in order to set it up, and the readout is going to be 0. Oh, I see. It's been counting. Okay. Let me think about it. I think it's been counting. Okay, so let's do another time. Let's see. Read this pulse. Okay, so now 0. I think it's because it's been counting for a little while. Okay, so now 0. Alright, so what I'll do next is I want to use an output. So I want to do output channel 1 to high, because channel 1 and channel 0 are connected. So I'm actually toggling, and then the H. Let's actually just do that once. So let's watch what happens here. It's going to only return a Z here, because this doesn't really get any data back, or a Z. And if I read the pulse back, I should just get a 1 pulse. There. Oops, there's a 0 pulse. Okay, let's see. Pulse 0. Alright, because it was already at high. So setting the this to high doesn't affect. It was already on high, so it doesn't have a transition. So let's have this on low. Okay. So this should cause the pulse counter to count 1. So high to low. There you go. That's 1. Okay. So I can do. This is a high on channel 1, and then low on channel 1 again. So basically I just flip the channel 1 up and down, so that counts as 2 pulses. So I'll just copy this command and send this out. 2 Z's because 2 commands. And if I read Z and pulse 0, this should give me 2 pulse, 2 counts right here. There we go. So what if I flip this up, down, say maybe 10 times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there should be 20 transitions, up, high to low, low to high. High, low. Okay. So let's read the pulse in, and that should be a. Okay, send that. There should be a 20 right there. Okay, so that's just an example of how to read the pulses and how to set digital outputs to the high or low. So okay, it's a relatively long video, so thanks for watching through all this. Hopefully this helps you solve your implementation issues of how do you have different channels doing different things and not affecting one another. Thank you.